Dear children, today we are going to see physics topic. Light reflection by spherical mirrors. Children, what we are going to learn? Tell me. Light. About light we are going to learn. So in light, reflection by spherical mirrors. Light ray, how it get reflected by spherical mirrors. Can you say once again? Reflection by spherical mirrors. Conceptual understanding. So what is meant by spherical mirror? What is meant by spherical mirror? A spherical mirror is a mirror whose reflecting surface is a part of a sphere. What is a spherical mirror? Whose reflecting surface is a part of a sphere. So reflecting surface is part of sphere. It has a curved reflecting surface. We will see in the diagram. A spherical mirror is a mirror whose reflecting surface is part of sphere. It has a curved reflecting surface, unlike a plane mirror which has a flat surface. So what is a spherical mirror? Spherical mirror is a mirror whose reflecting surface is part of a sphere. It has a curved reflecting surface. So spherical mirror is having curved reflecting surface. Plane mirror is having flat surface. Plane mirror is having flat surface which is reflecting. But spherical mirror is having curved reflecting surface. Two types of spherical mirrors. How many types of mirrors are there? Spherical mirrors. Two types of spherical mirrors. One is concave mirror, another one is convex mirror. So first one is concave mirror. The other name for concave mirror is converging mirror. What is another name for concave mirror? Converging mirror. What is another name for convex mirror? Diverging mirror. So concave mirror, that is converging mirror. Convex mirror, that is a diverging mirror. We will see what is converging, what is diverging, all that we will see. First we are going to learn about concave mirror. What is concave mirror? The inner curved surface of the sphere acts as the reflecting surface. It converges parallel rays to a focus. So inner curved surface. So if you are having a sphere, assume if you are having a sphere, if you cut the sphere, you will get two parts, right? One part, a smaller part and bigger part. If you cut it along with the diameter, you will get half of the spheres you are getting. So here, inner curved surface of sphere. You are taking hollow, empty sphere. Okay, what you are taking? Hollow glass sphere you are taking. Hollow glass sphere, and you are cutting it. So you are getting two parts. One is bigger part, one is a smaller part. Assume that one is a smaller part and other one is a bigger part. Smaller part I have taken. So one side silver coated and another side reflecting surface. So here inner curved surface is reflecting surface. I am taking inner curved surface, inside part. Inner curved surface I am taking. Inner curved surface is reflecting reflecting surface. Inner curved surface I am taking as a reflecting surface. Outer curved surface silver coated. Outside silver coated, inside the sphere. So inner curved surface of the sphere is a reflecting surface. That mirror is known as a concave mirror. So that mirror is known as a concave mirror. So it converges parallel rays. Whenever the parallel rays are coming and falling on the mirror, then whenever parallel rays falls on the mirror, how they get reflected, that is what we are studying here. So parallel rays, when they fall on the mirror, they reflect parallel rays, they reflect passing through a focus. What is focus? What is the center of curvature? What is pole? What is principal axis? All that I will discuss now. So if you take a sphere, hollow sphere, that sphere is having center, right? That the center is known as, that the center capital C, we will call it as center of curvature. And the distance between pole means if you take a part of the sphere, center of the mirror is known as pole. From pole to center of curvature, center of that sphere. For which sphere it is the mirror is part. For which sphere the mirror being a part. So if we take a distance between mirror at the center, the point at the center is known as pole. So distance between pole and center of curvature is known as radius of curvature. Radius. Distance between pole and center is known as radius, right? Radius of curvature. We say here radius of curvature. So in between pole and the center of curvature, exactly if you take in the middle, that point is known as focus. That point is known as focus. F, capital F, focus. So it converges parallel rays to a focus. Whenever they fall on the mirror, then they will reflect back passing through focus. What is the focus? And all that I will show in the diagram. Now convex mirror. What is convex mirror? The outer curved surface of the sphere acts as the reflecting surface. So which one is acting as a reflecting surface for convex mirror? Outer curved surface. Outside of the sphere. Outside the sphere. That is, the outer curved surface is acting as a reflecting surface. Inner curved surface we have silver coated it is painted. This convex mirror is having another name, diverging mirror. So it diverges the parallel rays. Whenever the ray comes and falls on the mirror, it reflects away from the focus, away from the principal axis. What is principal axis? I will tell you. So what is concave mirror? Inner curved surface of the sphere. Inner curved surface of the sphere acts as the reflecting surface. That only you have to remember. So what is concave mirror? Inner curved surface of the sphere acts as the reflecting surface. Okay. Next, what is convex mirror? Outer curved surface. We have to remember that. For concave mirror, inner curved surface is reflecting surface. For convex mirror, outer curved surface is reflecting surface. So that is the difference. What is concave mirror? What is convex mirror? Understood? What is concave mirror? Inner curved surface of the sphere. Inner curved surface of the sphere acts as a reflecting surface. What is outer curved? What is convex mirror? Outer curved surface of the mirror acts as a reflecting surface. That mirror is known as convex mirror. What is the other name for concave mirror? Converging mirror. What is the other name for convex mirror? Diverging mirror. Okay, we will see all those in the diagrams. See here, this is a sphere. Assume this is hollow glass sphere. This is also hollow glass sphere. Okay. Here I am taking a part. This part. Cut here. This is the part I am getting. So what about this part? Outer curved surface is a reflecting surface. Inner curved surface is silver coated. See here, shaded part. This is shaded part. Inner curved surface is silver coated. So outer curved surface is a reflecting surface. Whenever the rays comes from this side and whenever they fall on the mirror, then they reflect. They will diverge. Like this it will go. So here, if you observe this sphere, center, what is the center? Here, this is a sphere. This is the center of the sphere. So for this mirror, we are calling from pole to pole. Here see P. P is pole. Center of the mirror. At the center of the mirror, this one. Center of the mirror. That point is known as pole. From pole to center. From pole to center of curvature. We say this is center of curvature. This is a curved mirror, right? So we say this is a center of curvature. So distance between pole and the center of curvature is known as radius of curvature. Okay, this is convex mirror. So this is a convex mirror. Why I am saying this is convex mirror? Because outer curved surface is a reflecting surface, inner curved surface a painted surface. So if outer curved surface is a reflecting surface, we say that mirror is convex mirror. Got it? Now come to concave mirror. So assume this is a sphere. So if we cut it, so here inner curved surface is a reflecting surface. Inner curved surface is a reflecting surface. Outer curved surface is painted surface, silver coated surface. So that is concave mirror. Why we are saying this as concave mirror? If inner curved surface is a reflecting surface, we say that mirror is concave mirror. Here, distance between center of curvature and pole, distance between center of curvature and pole is known as radius of curvature. So here also the same, right? Distance between pole and the center of curvature is known as radius of curvature. Here also distance between pole and center of curvature is known as radius of curvature. See here, what is the difference between convex mirror and concave mirror? Here outer surface is a reflecting surface. This is in front of the mirror. So this is the front side of the mirror. Here you can see in front of the mirror, you are having center of curvature. But here back side of the mirror you are having center of curvature. In front of the mirror, that is in front of the reflecting surface. This is the reflecting surface. Here back side of this mirror, you are having center of curvature. But here in front of the mirror you are having center of curvature. Exactly in between P and C, if you take a half of PC, you will get exactly at the center, you will get the point. That point is known as focus. That point we are calling as focus, capital F. Okay, here also in between P and C, exactly in the middle, you will have focus, point focus you will have. Okay, what you have identified in these two mirrors? So outer curved surface is reflecting surface, that is convex mirror. So for convex mirror, center of curvature and focus, these are back side of the mirror. Got it? In case of concave mirror, focus, center of curvature are in front of the mirror, Okay, if you join pole and center of curvature, and if you extend it, that that is known as the line. Whatever we are getting is known as principal axis. What we call principal axis? The line which is joining pole and center of curvature. Got it? The line which is joining pole and center of curvature is known as principal axis. What we call? This is principal axis. Okay. So we learnt about center of curvature, about radius of curvature, and in between P and C, exactly in the middle you will have focus also, and here aperture. You are seeing here aperture. So the diameter of the mirror. So here length, you can say length, the width of the mirror, you can say the width of the mirror, this height, this entire height, right? This is known as aperture of the mirror, aperture. So terms related to spherical mirrors. Pole, we represent it by capital letter P. How we represent pole? Capital letter P. The center of the reflecting surface of a spherical mirror. So center of the spherical mirror. Spherical means it is round, right? It is like circle, circular shape it is having. And then if we take a part of, that is part of the sphere, that is a part of sphere. If we cut the sphere, we get two parts. One is a smaller part, one is bigger part. That smaller part we have taken, and we are discussing the pole, center of the reflecting surface of a spherical mirror, center of that circular plate, like circular mirror. So spherical mirror we say. Center of that spherical mirror is known as pole P. Center of curvature. The center of sphere of which the mirror is a part. The center of the sphere of which the mirror is a part. So center of curvature means C. C is the center of sphere. That capital C is known as center for the sphere. So what we say here, center of the curvature means the center of sphere of which the mirror is a part. The center of the sphere of which the mirror is a part. So we are having the mirror, that mirror is part of some sphere. So that sphere center is known as center of curvature. This mirror, center of curvature. We call that C is a center of curvature. Now principal axis. What is principal axis? The straight line passing through the pole and the center of curvature. So we have seen the line which is joining pole and the center of curvature. The line which is joining pole and the center of curvature is known as a principal axis. If we extend both sides, join pole and center of curvature and extend both sides, so that line acts as a principal axis. So if asks principal axis, what you have to say? The line which is joining pole and the center of curvature. The line which is joining pole and the center of curvature is known as principal axis. Got it? Now radius of curvature R. So distance between pole and the center of curvature. So what is the radius of curvature? Distance between pole and distance between pole and center of curvature, distance between pole and center of curvature is known as radius of curvature, capital R. We represent it by capital R, radius of curvature. So that is what the definition for radius of curvature. Radius of curvature or distance between pole and center of curvature. Here you can see applications, real life examples we will see. So the mirror used in shaving mirrors, the mirror used in shaving mirrors, the mirror used in shaving mirrors and dentist mirrors is a concave mirror. So if you go and visit a dentist, there you will see dentist using concave mirror. If you go for shaving in hair cutting shop, you will see what you will see, shaving mirrors, spherical mirrors you will see, spherical mirror, that is shaving mirrors. The mirrors used in shaving mirrors, dentist mirrors is a concave mirror. So what mirror you are using, what mirror you are using in shaving mirror and dentist mirror? That is concave mirror, not convex mirror. Concave mirror is used used as a concave mirror is used as a shaving mirror. Concave mirror is used as a dentist mirror. So dentist will use concave mirror. Next, rear view mirrors in vehicles. Rear view mirrors in vehicles are convex mirrors. Side mirrors you will have in vehicles, side mirrors. So those are rear view mirrors, rear view. So what are the applications here? So for vehicles, as a rear view mirror, we use convex mirror. So concave mirror where we are using? So for shaving purpose, concave mirror we use, and where we use concave mirror? Dentist also uses concave mirror to see the teeth, to make it enlarge and show. That the concave mirror will be helpful. Even for shaving also, it will show, maximize and show our face. So we are using concave mirror for shaving, and the dentist also using concave mirror. Rear view mirrors. Rear view mirrors. So what we are using rear view mirror as rear view mirrors? Convex mirror. What the convex mirror will do? So it will cover wider field of view. It will show wider field of view. It will show. So that's why we are using convex mirror as a rear view mirror. So convex mirrors give a wider field of view. Convex mirrors give a wider field of view. So difference between concave and convex mirrors. What is the difference between concave mirror and convex mirror? Here differences I gave. See here differences. Shape. Coming to shape, concave mirror, that is inward curved surface, right? Inner curved surface. Otherwise inward curved you can say. Like inside of a spoon. So inward curved means inside of a spoon. So convex mirror, what about the shape of convex mirror? Outer curved, like back of a spoon, Now type of reflection. Concave mirror, how it reflects? Converges light rays to a point. Converges light rays to a focus. To a point, that point is known as focus. So here, coming to convex mirror, diverges light rays away from a point. Where this focus will lie on principal axis, in between pole and center of curvature. Exactly in the middle. In between pole and center of curvature, you will have focus. So all the rays after reflection, parallel rays, or the parallel rays after reflection, they will pass through focus. So focus position in case of concave mirror, focus where it will lie, in front of the mirror, in front of the reflecting surface. In front of the reflecting surface, focus position is there. But coming to convex mirror, where the focus is behind the mirror, not in front of the reflecting surface. Where the focus in case of convex mirror, behind the mirror, we are having focus behind the mirror in case of convex mirror. Now coming to image formation. So concave mirror, how it will form the image? It can form real and inverted or virtual and direct images. So concave mirror can form real image, virtual image. Real image means if we are able to catch the image on screen, then that is known as real image. What is virtual image? If we are unable to catch it on the screen, then we say that the image is virtual image. So can form real and inverted. So concave mirror can form real image and inverted image. Or some cases it is forming even virtual and erect images also. Virtual and erect image. So based on object position, you are getting whether it is real or inverted, whether it is virtual and erect, based on the position of the object in front of the mirror. Based on the position of the object, we are getting whether a real number or a virtual image. Real image or virtual image. Real image means we can able to catch it on screen in front of the mirror. If we put some screen, so we will get the image of the object on the screen. But coming to convex mirror, always forms virtual. Erect, always forms virtual, erect and diminished images in case of convex mirror. So concave mirror gives both types, right? Real and inverted it gives in some cases. In one case it is giving even virtual and erect image. But concave mirror always gives virtual, erect, diminished image only. Diminished means reduced in size. So all these we will study. Object we will take at different positions in front of the mirror and where the image will be formed. All that we will discuss. Some more differences. Concave mirror used in torches, headlights, shaving mirrors, solar cookers. Convex mirror, where we are using convex mirror, we use as rear view mirrors in vehicles. Security mirrors in ATM centers. Concave mirror, it forms image at infinity, real, inverted, formed at the focus. So here if we take the object at infinity, taking the object at infinite distance, and we are getting the image at focus, real, inverted, formed at the focus, real, inverted image, formed at the focus. So you take object at infinity. If you take object at infinite distance, what about convex mirror? It will form virtual image, erect erect means upright image only, not inverted. Upright image. Same like as it is, as the object. Same like as object, you will get upright image. So virtual, erect, highly diminished at the focus behind the mirror. So behind the mirror, it gives the image. The image will be formed behind the mirror. So that's why we are saying it is virtual. Virtual, erect, highly diminished. Virtual image, we are unable to catch it on the screen. That's why this is virtual image. Erect image, highly diminished, highly reduced image we will get. Now field of view, in case of concave mirror, narrower field of view. So it will be showing narrower field of view. But coming to convex mirror, it will cover wider field of view. It will show wider field of view, it will show. That's why in vehicles we are using convex mirror as a rear view mirrors. Backside, all the vehicles, almost all the backside, it will show in the mirror. So rear view mirror. Convex mirror we are using as a rear view mirror. Nature of image. So for concave mirror, what is the nature of image of the object? So real, inverted, when object is not too close to the mirror. When object is not too close to the mirror, then you will get a real inverted image. Real inverted image you will get. If object is very closer to the mirror, very closer to the mirror, that is in between pole and focus, in between pole and focus, then you will get virtual image. Then you will get for concave mirror also you will get virtual image. That is behind the mirror you will get the image. Behind the mirror you will get the image, so that we will be unable to catch it on the screen. Convex mirror always virtual and direct image. Always it gives, convex mirror always gives virtual and direct image only. Here concave mirrors converge light and can produce both real and inverted image. Convex mirrors diverge light and always produce virtual erect and small images, diminished images. Ray diagram construction. Now we are going to study about ray diagrams. Why is it sufficient to consider only two rays while constructing a ray diagram for spherical mirrors? It is sufficient to consider only two rays while constructing a ray diagram for spherical mirrors, because they are enough. Two rays are enough to accurately locate the position of image. So while we want to draw ray diagram for the image formation of the object, so in front of the spherical mirror you are taking some object. So light source you are taking in front of the mirror, light source you are taking, candle, burning candle you may take. So whenever the light rays fall on the mirror, how they reflect. Here two rays we will consider. One is parallel ray we will consider, and another one the ray which is passing through focus of the mirror. Otherwise the ray which is passing through center of curvature of the mirror. Otherwise the ray which falls obliquely at the pole of the mirror, So the ray which is making some angle with the principal axis, that is known as obliquely, it is coming to the pole. The ray which falls at the pole of the mirror, making some angle with the principal axis. That we will see in the diagrams. So in all those cases, we will consider only two rays. Only two rays we will consider, and after reflection, where they are intersecting. Based on that, we will discuss. How it forms the image. How it forms the image of the given object. See here, clarity and simplicity. An infinite number of light rays accurately emerge from each point on an object, but for drawing purposes, considering only two rays is sufficient. For drawing purpose, what we have to do? Only two rays is sufficient. To consider only two rays is sufficient to locate the image, where the image will be formed. To locate that, it is sufficient to consider only two rays. The image is formed at the point. The image is formed at the point where the reflected rays intersect. Where the reflected rays intersect. So the image is formed at the point where the reflected rays intersect, or if they are not intersecting, their extensions, backside, if you extend backside of the mirror, if you extend that ray after reflection, that reflected ray, if you extend backside of the mirror, there it will appear that they are intersecting backside of the mirror. So there the image will be formed. That is virtual image. Important rays used in ray diagrams. Certain rays have predictable paths after reflection. A ray parallel to the principal axis passes through the focus. A ray parallel to the principal axis passes through the focus. A ray parallel to the principal axis appears to come from the focus in case of convex mirror. In case of concave mirror, a ray parallel to the principal axis passes through the focus. A ray passing through the center of curvature reflects back along the same path. A ray passes through the focus, reflects parallel to the principal axis. A ray striking the pole obeys the law of reflection. The angle of incidence is equal to angle of reflection. Here parallel ray, the ray which is passing through center of curvature, the ray which is passing through focus, a ray striking the pole obeys the law of reflection. So about four rays we are seeing here, about four rays. The ray which is parallel to principal axis, and the next one, the ray which is passing through center of curvature. Next one, a ray passing through the focus. Next one, a ray striking the pole obeys laws of reflection. So angle of incidence is equal to angle of reflection. About these four rays, we can predict how it behaves. Certain rays have predictable paths after reflection. So the ray which is parallel to principal axis, how we can predict after reflection how it moves, how it will. So after reflection, it will pass through the focus. A ray passing through the center of curvature, after reflection, back along the same path. So a ray which is passing through center of curvature, it will come along the same path. It will come back along the same path, because that acts as normal, right? That is the only normal at the center, at the point on the mirror. A ray passing through the center of curvature reflects back along the same path. A ray passing through the focus, reflects parallel to the principal axis. All these we will see in the diagrams. Any two of the above rays are sufficient to accurately locate the image formed by a spherical mirror. More rays may be used for better accuracy, but 2 rays are enough to construct a clear and correct ray diagram. To construct a clear and correct ray diagram, how many rays we are considering? 2 rays. 2 rays are enough to draw the image of the for the given object. To draw the image for the given object, how many rays we can consider? 2 rays. Enough to consider 2 rays. That is key idea. So ray diagram rule 1, concave mirror. How does a ray parallel to the principal axis behave in a concave mirror? A ray parallel to the principal axis reflects and passes through the principal focus of the concave mirror. A concave mirror is a converging mirror. Hence, parallel rays after reflection meet at the focus F. All the parallel rays after reflection meet at the focus F. Concave mirror ray diagram rule 1. Ray diagram of concave mirror rule 1. We say this is rule 1. So if we consider parallel ray, how it reflects? A ray which is parallel to the principal axis. Here, see, this is principal axis to the mirror. This is concave mirror. At the center, you are having pole. This is pole. This is the center of curvature. Exactly in the middle, in between P and C, the midpoint is focus. After reflection, the ray which is parallel to the principal axis, after reflection passing through focus. This is rule 1. Ray diagram of concave mirror, rule 1. C is the center of curvature, F is focus, P is pole. Parallel ray reflects, passes through focus. Parallel ray after reflection passes through focus. After reflection passes through focus. So what is rule 1? Can you say? Parallel ray after reflection passes through focus. That's all. Parallel ray after reflection passes through focus. So ray diagram rule 1, convex mirror. Now we are going to see for convex mirror. How does a ray parallel to the principal axis behave in a convex mirror? A ray parallel to the principal axis reflects and appears to come from the principal focus behind the mirror. మీకు అర్థమవుతుందా ఇక్కడ? A ray parallel to the principal axis. ప్రిన్సిపల్ యాక్సిస్కి ప్యారలల్గా ఉన్నటువంటి రేని మనం కన్సిడర్ చేసుకున్నట్లయితే అది రిఫ్లెక్ట్ అయిన తర్వాత మనకి ఎలా కనపడుతూ ఉంటుందంటే ఫోకస్ గుండా ఈ రే వస్తుంది, ఫోకస్ నుండి ఈ రే వస్తుంది అన్నట్టు కనపడుతుంది అనమాట. ఫోకస్ ఎక్కడ ఉంటుంది? కాన్వెక్స్ మిర్రర్లో బ్యాక్ సైడ్ ఆఫ్ ద మిర్రర్ ఫోకస్ ఉంటుంది. ఫోకస్ ఎక్కడ ఉంటుంది? బ్యాక్ సైడ్ ఆఫ్ ద మిర్రర్ ఫోకస్ ఉంటుంది ఇక్కడ కాన్వెక్స్ మిర్రర్లో అయితే. Explanation: a convex mirror is a diverging mirror. So reflected rays spread out, but when these rays are extended backward, they seem to originate from the focus F behind the mirror. We will see the diagram. See this diagram. This is a convex mirror. So outer curved surface is a reflecting surface. Inner surface is a silver coated surface. If outer surface is reflecting surface, we say that mirror is convex mirror. So ఇది కాన్వెక్స్ మిర్రర్. ఎందుకంటే ఈ బయట ఉన్నటువంటి అవుటర్ కర్వ్డ్ సర్ఫేస్కి అవుటర్ కర్వ్డ్ సర్ఫేసే మనకి రిఫ్లెక్టింగ్ సర్ఫేస్గా పనిచేస్తుంది ఇక్కడ. సో ఇన్నర్ కర్వ్డ్ సర్ఫేస్ ఉంది చూసారా, అది సిల్వర్ కోటెడ్ సర్ఫేస్ అన్నమాట. అందుకని దీన్ని ఏమంటున్నాము, కాన్వెక్స్ మిర్రర్ అంటున్నాము. సో ఇప్పుడు ఏ రేని తీసుకున్నాను, ఇది రే ఇది ఈ రే అనేది ఏంటి, ఈ లైన్ని మనం ఏమని పిలుస్తున్నాము, ఈ లైన్ని మనము ప్రిన్సిపల్ యాక్సిస్ అని పిలుస్తున్నాము. ఎందుకని ప్రిన్సిపల్ యాక్సిస్ అని పిలుస్తున్నాము, దిస్ ఈజ్ ద లైన్ జాయినింగ్ ద పోల్ అండ్ సెంటర్ ఆఫ్ కర్వేచర్. ఏ లైన్ విచ్ జాయిన్స్ పోల్ అండ్ సెంటర్ ఆఫ్ కర్వేచర్ ఈజ్ నోన్ యాజ్ ప్రిన్సిపల్ యాక్సిస్. దట్ ఈస్ డెఫినేషన్ ఫర్ ప్రిన్సిపల్ యాక్సిస్. సో ప్రిన్సిపల్ యాక్సిస్ అంటే అర్థమవుతుందా, పోల్ని సెంటర్ ఆఫ్ కర్వేచర్ని జాయిన్ చేసినట్లయితే, జాయిన్ చేసి రెండు వైపులు ఎక్స్టెండ్ చేసామనుకోండి, వచ్చిన దాన్ని మనం ఏమంటున్నాము, ప్రిన్సిపల్ యాక్సిస్ అంటున్నాము. సో ఇప్పుడు ఈ ప్రిన్సిపల్ యాక్సిస్కి, ఇది ప్రిన్సిపల్ యాక్సిస్ కదా, ఈ ప్రిన్సిపల్ యాక్సిస్కి ప్యారలల్గా ఇదిగో ఇక్కడ తీసుకున్నాను, ప్యారలల్ రేని కన్సిడర్ చేస్తున్నాను. ప్యారలల్ రే, ఈ ప్యారలల్ ఎక్కడో సోర్స్ నుంచి వస్తుంది ఈ రే, లైట్ రే వచ్చేసి వెన్ ఎవర్ ఇట్ ఫాల్స్ ఆన్ ద మిర్రర్, హౌ ఇట్ రిఫ్లెక్ట్స్, it is going away from the, this is principal axis, right? It is going away from the principal axis. So in such a way it will reflect. That we call it is a diverging. So if the reflected ray, if we extend it back, then it will pass through focus. How the reflected ray appears to us? The reflected ray appearing to us, it is generated from focus. The ray seems that it is coming from the focus. ఆ రే ఫోకస్ నుండి జనరేట్ అయి వస్తుంది అన్నట్టుగా కనపడుతుంది అనమాట రిఫ్లెక్ట్ అయినటువంటి రే. సో ఇక్కడ పి అంటే పోలు, ఎఫ్ అంటే ఫోకస్, సి అంటే సెంటర్ ఆఫ్ కర్వేచర్. సో వాట్ ఈస్ పాత్ హియర్, parallel rays reflects. Parallel rays reflects appears to come from focus. Parallel rays reflects appears to come from focus F. Appears to come from focus F behind the mirror. Focus is behind the mirror. Ray diagram rule 2. What happens to a ray passing through the principal focus after reflection? So the ray which is passing through focus, we say principal focus also. Otherwise we can say simply focus also. So what happens to a ray passing through the principal focus after reflection? A ray of light passing through the principal focus for a concave mirror. A ray passing through focus of a concave mirror after reflection, it will be parallel to principal axis. After reflection, it will be parallel to principal axis. For concave mirror, a ray passing through the principal focus of a concave mirror reflects parallel to the principal axis. Reflects parallel to the principal axis. So what is rule here? A ray passing through the focus is reflected parallel to the principal axis. A ray passing through the focus after reflection, it is parallel to principal axis. This you should be able to draw. Okay, this is the ray passing through the focus and reflecting parallel to the principal axis. In case of concave mirror, the ray which is passing through focus, after reflection it will be parallel to principal axis. See here, in case of convex mirror, focus and the center of curvature, where these are lying, back side of the mirror. Back side of the mirror, focus and the center of curvature lying. So this is pole, this is focus, this is center of curvature. Outer curved surface is reflecting surface. The ray which is coming, whenever the ray falls on the mirror, the ray which is coming towards focus, the ray which is coming towards focus, how it reflects? It will reflect parallel to the principal axis. So a ray directed towards the focus, here this is the ray directed towards the focus, reflects parallel to the principal axis. Now ray diagram rule 3, concave mirror. Explain what happens to a ray passing through the center of curvature of a concave mirror. When a ray of light passes through the center of curvature C of a concave mirror, it is reflected back along the same path. It will be reflected along the same path. సో ఇక్కడ మీకు అర్థమవుతుందా? ఏదైనా ఒక రేని సెంటర్ ఆఫ్ కర్వేచర్ గుండా వెళ్ళేటటువంటి రేని మీరు కన్సిడర్ చేసినట్లయితే, అది సెంటర్ ఆఫ్ కర్వేచర్ గుండా వెళ్ళి మిర్రర్ మీద పడిన తర్వాత అది సేమ్ పాత్లోనే రిఫ్లెక్ట్ అవుతుందన్నమాట. ఎలా వెళ్ళిందో అదే వేలో బ్యాక్ రిఫ్లెక్షన్ అవుతుందన్నమాట, అదే వేలో వస్తుంది. సో దీన్ని ఏమంటున్నారు? A ray of light passes through the center of curvature of concave mirror. It is reflected back along the same path. It is reflected back along the same path. So the center of curvature C is the center of the sphere. Center of curvature is the center of the sphere of which the concave mirror forms a part. సో సెంటర్ ఆఫ్ కర్వేచర్ క్యాపిటల్ సి. ఈ క్యాపిటల్ సి అనేది సెంటర్ ఆఫ్ కర్వేచర్ అనేది ఏంటంటే, ఆ స్పియర్కి సెంటర్ ఏదైతే ఉందో ఆ సెంటర్నే మనం సెంటర్ ఆఫ్ కర్వేచర్ అంటున్నాము. ఏ రే పాసింగ్ త్రూ ద సెంటర్ ఆఫ్ కర్వేచర్ స్ట్రైక్స్ ద మిర్రర్ నార్మల్లీ. ఏ రే అయితే సెంటర్ ఆఫ్ కర్వేచర్ గుండా పాస్ అయ్యి మిర్రర్ మీద పడిందో దాన్ని ఏమంటున్నారంటే నార్మల్ అంటున్నాము. దాన్ని ఏమంటున్నాము? నార్మల్ అంటున్నాము. అక్కడి నుంచి అది ఎలా రిఫ్లెక్ట్ అవుతుంది? మళ్ళా సెంటర్ ఆఫ్ కర్వేచర్లో నుండి వెళ్ళే విధంగానే రిఫ్లెక్ట్ అవుతుంది అనమాట. A ray passing through the center of curvature strikes the mirror normally. Strikes the mirror normally. Normal. So therefore the angle of incidence is equal to angle of reflection. సో ఎప్పుడైతే సెంటర్ ఆఫ్ కర్వేచర్ గుండా వెళ్ళి మనకి అదే పాత్లో రిఫ్లెక్ట్ అయిందో అప్పుడు యాంగిల్ ఆఫ్ ఇన్సిడెన్స్ జీరోనే ఉంది, యాంగిల్ ఆఫ్ రిఫ్లెక్షన్ కూడా జీరోనే ఉందన్నమాట. రే రీట్రేసెస్ ఇట్స్ పాత్ ఆఫ్టర్ రిఫ్లెక్షన్. ఆఫ్టర్ రిఫ్లెక్షన్ ఆ పాత్ని రీట్రేస్ చేసింది. సో రే డయాగ్రామ్ రూల్ 3 ఫర్ కాన్కేవ్ మిర్రర్. రే పాసింగ్ త్రూ ద సెంటర్ ఆఫ్ కర్వేచర్. రే పాసింగ్ త్రూ ద సెంటర్ ఆఫ్ కర్వేచర్. ఎనీ రే పాసింగ్ త్రూ ద సెంటర్ ఆఫ్ కర్వేచర్ స్ట్రైక్స్ ద మిర్రర్ పర్పెండిక్యులర్లీ. A ray passing through the center of curvature C strikes the mirror perpendicularly. Strikes the mirror perpendicularly. సో ఏదైనా ఒక రే సెంటర్ ఆఫ్ కర్వేచర్ గుండా వెళ్ళి మిర్రర్ మీద పడ్డదంటే ఆ మిర్రర్ మీద ఉన్నటువంటి ఆ పాయింట్ దగ్గర ఇది పర్పెండిక్యులర్గా ఉందన్నమాట. దిస్ మీన్స్ దట్ ద రే ఈజ్ నార్మల్ టు ద మిర్రర్ సర్ఫేస్ ఎట్ ద పాయింట్. సో మిర్రర్ సర్ఫేస్ దగ్గర ఏ పాయింట్ అని తీసుకోండి, ఆ పాయింట్ దగ్గర వచ్చినటువంటి రే సెంటర్ ఆఫ్ కర్వేచర్ నుంచి పాస్ అయ్యి అక్కడికి వచ్చింది అనుకోండి, అప్పుడు ఆ రేని ఆ సెంటర్ ఆఫ్ మిర్రర్కి ఏమంటారు, పర్పెండిక్యులర్ అంటాం. ఎనీ రే పాసింగ్ త్రూ ద సెంటర్ ఆఫ్ కర్వేచర్ స్ట్రైక్స్ ద మిర్రర్ పర్పెండిక్యులర్లీ. This means the ray is normal to the mirror surface at that point. Coming to result, the ray reflects back along the same path. The ray reflects back along the same path because angle of incidence equal to 0. So whenever the line passing through the center of curvature, what we can say, the line passing through center of curvature is 0. Sorry. The ray reflects back along the same path because the angle of incidence is equal to 0. So what is the result here? The ray reflects back along the same path because the angle of incidence is equal to 0. And according to the law of reflection, angle of reflection equal to 0. So angle of incidence is equal to angle of reflection is equal to 0 according to the law of reflection. Now you can see this diagram. This is the ray passing through the center of curvature, and after reflection it will retrace the same path. Ray through the center of curvature is like this. Coming to summary, incident ray passing through the center of curvature, passes through the center of curvature. Reflected ray returns along the same path. Reason, the ray strikes the mirror perpendicularly. Normal incidence. So all these points about this line only, this ray. So the ray which is passing through center of curvature, when it falls on the mirror, it will retrace the same path. So reflection along the normal. Why does a ray incident along the normal reflect back on the same path? When a ray of light falls along the normal to the surface of a mirror, it reflects back along the same path. This happens due to law of reflection. It strikes the mirror perpendicularly. When a ray of light falls along the normal to the surface, it reflects back along the same path. This happens due to law of reflection. So according to law of reflection, the angle of incidence is equal to angle of reflection, F. The normal is the line drawn perpendicular to the mirror surface. The normal is the line drawn perpendicular to the mirror surface at the So here the normal is the line drawn perpendicular to the mirror surface at the angle of incidence. Here you can write angle of incidence, at the angle of incidence. Normal is the line drawn perpendicular to the mirror surface at the point of incidence. At the point of incidence, we will draw the normal. The normal is the line drawn perpendicular to the mirror surface at the point of incidence. Why the ray retraces its path? Why the ray retraces its path? If a ray is incident along the normal, if a ray is incident along the normal, the angle of incidence is 0 degrees. According to the law of reflection, angle of incidence is equal to angle of refraction. Sorry, angle of incidence is equal to angle of reflection, not refraction, reflection. Therefore, angle of refraction is also 0 degrees here. So, angle of incidence is 0, angle of reflection also 0. If the ray passing through the center of curvature, then what about the reflection? Angle of incidence is equal to angle of reflection. Therefore, the angle of reflection is also 0 degrees. Hence, the ray retraces its path after reflection. So, if we want to say in simple words, a ray incident normally on a mirror does not change direction after reflection. So, how does a ray incident obliquely towards the pole behave after reflection? Law of reflection at pole. When a ray is incident obliquely at an angle towards the pole P of the spherical mirror, it reflects according to the law of reflection, just like a plane mirror. Important points here: the pole P is the middle point of the mirror. The normal at the pole is along the principal axis. The normal at the pole is along the principal axis. Therefore, the ray reflects such that angle of incidence is equal to angle of reflection. Now you can see oblique ray at pole. This is oblique ray at pole. The ray which is oblique at pole, how it is reflecting? It is making same angle with the principal axis. So if an oblique ray strikes the mirror at the pole, it reflects to other side of the principal axis. It reflects to the other side of the principal axis. It makes equal angles with the principal axis. Here the angle with the principal axis. Here also the line which is making angle with the principal axis will be same. In simple words, an oblique ray hitting the pole becomes bounces. So here see, in simple words, an oblique ray hitting the pole bounces symmetrically. An oblique ray hitting the pole bounces symmetrically. Bounces symmetrically. Now you can see in case of convex mirror, oblique ray at pole. This is oblique ray at pole. Same rule applies at the pole. Principal axis acts as the normal at P. So at point P, principal axis, how it works? Principal axis is normal. So here see, principal axis acts as the normal at P. Principal axis acts as normal at P. The ray reflects such that, so how it is reflecting? Here you measure the angle I, and here if you measure the angle R. So angle I is equal to angle R you will get. Reflection is symmetric about the principal axis. So this reflection symmetric about principal axis. This is principal axis. In case of convex mirror, where the focus behind the mirror, where the center of curvature behind the mirror. Now, laws of refraction in spherical mirrors. Why do the reflected rays follow the law of reflection in spherical mirrors? Reflected rays follow the laws of reflection in spherical mirrors because each small part of the spherical mirror behaves like a plane mirror. So each small part of spherical mirror behaves like a plane mirror. That's why reflected rays follows the laws of reflection in spherical mirrors because each small part of the spherical mirror, each small part of the spherical mirror behaves like a plane mirror. A spherical mirror is part of a sphere and its surface is smooth and curved. At any point on the mirror, we can draw tangents. The normal at the point is drawn perpendicular to the tangent. Why reflection laws still apply? When a light ray strikes any point on the spherical mirror, that small portion behaves just like a plane mirror. Therefore, it follows the law of reflection. So, angle of incidence is equal to angle of reflection. The incident ray, reflected ray and normal lie in the same plane. All these three, incident ray, reflected ray and normal, lie in the same plane. In simple words, even though the mirror is curved, every smaller part of it behaves like a flat mirror. The laws of reflection apply perfectly. Significance of pole, focus and center of curvature. What is the significance of the pole, focus and center of curvature in a mirror? Pole P. The pole P is the geometric center of the mirror's surface. It is the midpoint of the reflecting surface. All the important distances such as object distance, image distance, focal length are measured from the pole. So all distances we are measuring from the pole. The distance from pole to object is known as object distance. The distance from pole to image is known as image distance. The distance from pole to focus is known as focal length. So it acts as the reference point in a ray diagram. So pole P acts as a reference point in ray diagrams. Focus of a spherical mirror. The focus F is the point where rays parallel to the principal axis converge after reflection in a concave mirror. Appear to diverge from in a convex mirror. So here you should know what the focus is. The focus F is point where rays parallel to the principal axis converge. So where the parallel rays are converging after reflection, converging to the focus. So the focus F is the point where rays parallel to the principal axis converge after reflection in a concave mirror. That is the definition. So what is the focus for convex mirror? The focus F is the point where rays parallel to the principal axis appear to diverge from focus in a convex mirror. The focus lie midway between the pole and center of curvature. See, the distance between pole and focus is called focal length. What is focal length? Distance between pole and focus, PF. We represent it by small letter f, distance. The distance between pole and focus is called focal length. So distance between P and F, we represent it by PF. That is the focal length, small f. The focus is important in locating images in ray diagrams. In ray diagrams, to locate the images, the focus is playing very important role. Now center of curvature. The center of curvature C. The center of curvature C is the center of the sphere of which the mirror is a part. Center of curvature is the center of the sphere of which the mirror is part. For a concave mirror, it lies in front of the mirror. For concave mirror, where center of curvature? In front of the mirror. For a convex mirror, where it lies behind the mirror. A ray passing through the center of curvature reflects back along the same path. A ray passing through the center of curvature reflects back along the same path. Key terms in spherical mirrors. Pole, we represent it by P. So center of meaning center of mirror's surface. Center of mirror surface. Importance, reference point for all measurements. All measurements we measure from pole. We think pole as a starting point to measure all types of distances. In case of concave mirrors, in case of concave and convex mirrors. Now coming to focus F. What is this? Point where parallel rays meet or appear to diverge. So the point focus is the point where parallel rays meet at that point or appear to diverge. So this focus helps in locating images. Now coming to center of curvature, capital C, center of sphere of which mirror is a part. Center of sphere of which mirror is a part. So determines the curvature of mirror. Determines the curvature of the mirror. Center of curvature determines the curvature of the mirror. Now image formation by concave mirror. Describe the nature, position and the size of image when the object is placed at different positions. So we are considering concave mirror. So object position beyond C. If we take object beyond C, the image is formed between center of curvature and focus, and real inverted image you will get. The size of the image comparing with object, the size of the image is diminished image. If we take object at the center of curvature, image will be formed at center of curvature. So that is a real inverted image. Real inverted same size image you are getting at the center of curvature C. Between center of curvature and focus, you will get the image beyond center of curvature. Between C and F, if you take the object, you are getting the image beyond the center of curvature. That image is a real image, inverted image. That is enlarged image you are getting. If you take object at focus, image position at infinity, image position at longer distance, at infinity. So nature of image real inverted image. This is highly enlarged image you are going to get, highly enlarged image. Between F and P, if you take object between focus and pole, what about the image position? Behind the mirror. So nature of image virtual erect, enlarged. Size of image enlarged. If you take object at infinity, image will be formed at focus capital F, real inverted image, and you are getting point size image. You are getting point size image. Coming to concave mirror, object at infinity. So object placed at infinity. All the cases I am going to give the diagrams now. Object placed at infinity, image formation, position of image at the focus, position of image at the focus. So if you take object at infinity, where the image will be formed? At focus. You can observe the diagram. So this is the diagram. So this is object A, B. We have taken this as object. The ray which is parallel to principal axis, after reflection passes through focus. And here also the ray which is parallel to principal axis, after reflection passing through focus. So here position of image at the focus you are getting, nature of image, real and inverted image you are getting. Next, size of image, highly diminished, point sized, highly diminished. This point is highly diminished, point sized. For concave mirror, object beyond C. We have taken object at infinity first, and then we have taken object beyond center of curvature. Now taking object beyond center of curvature. Object at center of curvature, object at focus, all the cases we will discuss. Here image formation, position of image between C and F. If you take object between C and F, nature of image real and inverted. Size of image diminished. Size of image diminished. So beyond the center of curvature, the image will be formed. This is parallel ray after reflection passing through focus, and this is the ray which is passing through center of curvature, where the reflected rays are intersecting. So if you take object in between center of curvature and focus, the reflected rays intersecting in between C and F. Object if you take beyond center of curvature. This is earlier case diagram, not this case. This is earlier case diagram. So object taken beyond center of curvature, you are getting object image. in between C and F, in between C and F. So concave mirror object at C, object at C. First I have discussed object beyond center of curvature. After that, at the center of curvature, so image formation, position of image at C, position of image at center of curvature only. Nature of image real inverted, nature of image real inverted. Size of image same size as the object, same size as the object. So if you take object at the center of curvature, you are getting same size image. That is a real inverted image. Real inverted same size image you are getting. Now coming to concave mirror object between C and F. So object now you are taking in between C and F. In earlier case object taken beyond center of curvature and we got the image in between center of curvature and focus. But now we are taking object in between C and F and getting the image beyond center of curvature. So image formation, position of image beyond center of curvature, nature of image real and inverted, size of image enlarged, size of image enlarged, bigger than the object. So concave mirror object at focus, object placed at the focus F. Image formation, if you take object at focus, where you are getting the image at infinite distance, you are going to get the image. So position of image at infinity, you are getting image at infinite distance. Nature of image real and inverted. Size of image highly enlarged, highly enlarged. So here I have considered parallel ray. Parallel ray after reflection pass through the focus. I considered the ray which appears that it will pass through focus. So after reflection also it will retrace the same path. Concave mirror image formation. In which position does a concave mirror form real inverted and same sized image? A concave mirror forms real inverted and same sized image when the object is placed at the center of curvature. When the object is placed at the center of curvature of the mirror, you are getting real inverted and same sized image getting. Coming to summary, object position at C, center of curvature, image position at C, nature of image real and inverted, size of image same size as the object, same size as the object. This is a unique property of concave mirrors. What is unique property of concave mirrors? It can be clearly shown using ray diagram. A ray parallel to the principal axis reflects through the focus. A ray passing through the focus reflects parallel to the principal axis. So in which position does a concave mirror form real inverted and same sized image? At the center of curvature. Concave mirror image formation. When does a concave mirror form a virtual and direct image? If the object is taken in between pole and focus, it will form virtual erect image. So a concave mirror forms virtual and direct image when the object is between pole and focus of the mirror. Details: object position between pole and focus, image position behind the mirror, it will form the image behind the mirror. Nature of image virtual, cannot be obtained on a screen. and it is erect image. Size of image enlarged, larger than the object. Why this happens? In this position, the reflected rays diverge. Reflected rays diverge. However, their extensions behind the mirror appear to meet. This forms a virtual image that is erect and magnified.